everyone, we are lab rats and today we're going to show you how to solve gas stochiometry questions. There are three areas we're focusing today: density of gas, moles to volume and mass to volume calculations, and volume to volume calculations. So buckle up and let's get started.
Density equals to mass over volume. For the unit, it equals to grams over liter. TSTP is density in standard temperature and pressure condition. We can find TSTP of gases by multiplying molar mass to 1 mole over 22.4 liter. To find molar mass using TSTP, we write it as molar mass equals to TSTP multiplied by 22.4 liter over 1 mole. Here's an example. Calculate the density of C2H4 in STP. First, find molar mass of C2H4. Molar mass of carbon is 12.01 grams per mole and hydrogen is 1.008 grams per mole. Therefore, molar mass of C2H4 is 12.01 times 2 plus 1.008 times 4 equals to 28.052 grams per mole. Second, sub the molar mass of C2H4 into the formula and you will get the density. So, 28.052 times 1 mole over 22.4 liters equals 1.25 grams per liters.
So here we'll show you an example for volume to mass calculation. How many grams of C3H6 are present in 945 ml of the gas at STP? So the first step is to find the molar mass of C3H6. So the molar mass of C3H6 is 42.048 gram per mole. The second step is to find the density in STP. So the formula is molar mass equals to density times 22.4 L per mole. So the density is 1.877 gram per liter. The third step, which is the last step, to find the mass of C3H6. The formula is density equals to gram per liter. Don't forget to convert the volume from ml to L. So the volume is 0.945 liter. So the mass of C3H6 is 1.774 gram. So the next question is for volume to mole calculation. Calculate the volume of 5.89 mole of carbon dioxide at STP. So the first step is to find the molar mass of CO2, which is 44.01 gram per mole. The second step is to find the mass of CO2, which is 259.229 gram. The third step is to find the density, which is use the same formula to find the density, which is 1.965 gram per liter. The last step is to find the volume of CO2. Using the same formula, density equals to gram per L. And we found the volume is 132 L.
Now I'm going to explain volume to volume calculations. Based on Avogadro's law, for reacting gases at constant temperature and pressure, volume to volume relationships are the same as mole to mole relationships. Now let's look at the following equation. 1 mole of carbon plus 2 mole of hydrogen gives us 1 mole of methane. Proceeding to the question, how many liters of hydrogen are needed to produce 20 liters of methane? Now let's list out the stuffs we know. We know it's 20 liters of methane and we have to find hydrogen. First, we have to identify molar ratio of hydrogen and methane, which is 2:1. The next step explaining the equation. So 20 liters of methane times 2 mole of hydrogen over 1 mole of methane, which gives us 40 liters of hydrogen. See, that was simple enough. Now let's look at example number 2. We have 4 moles of NH3, 3 mole of oxygen, 3 mole of nitrogen, and 6 mole of water. The question being, what is the volume of NH3 gas will react with 22.5 liters of oxygen gas? Let's list down the things we know. It is 22 liters of oxygen, and we need to find the liters of NH3, which is ammonia. As usual, firstly we have to identify the mole ratio of oxygen and ammonia, which is 3:4. And proceeding to our next step, the calculation bit. So 22.5 liters of oxygen times 4 mole of NH3 over 3 mole of oxygen, which gives us 30 liters of NH3.